All right, welcome to Select Star. Now, tell me, is this your situation? Have you gone in, dug in, found out you had a query that wasn't that good? You fixed it, you rewrote it, you left out where clauses, but you added them in, and you probably did it. It did speed it up, but it's not yet sub-second. Where I come from, if it's not sub-second, it ain't a real query. What can you do to fix that? Well, you came to the right place because I went and got with me Mr. Doug Weatherby here, Senior Director of Training, who's been digging in for, gosh, at least the past 2 months of exactly how do we optimize queries with a good methodology, a good approach that is repeatable and reusable and can help us get to the bottom of things. So what do you got for us today, Doug?
Well, thanks, Greg. Yeah, this is a follow-on from the part one that Greg and I recorded last week. And what I have is, Greg, are you showing a slide right here?
Oh, let me switch to that. I was not. There we go.
No worries. Yeah. So what I did is I just threw up a slide here just to kind of give us a bit of a roadmap of where we are. If you all remember, last week I talked about SQL statement tuning methodology, and that broadly speaking, I had charted out sort of 6 steps right here. You would do a load test, and then you would use DB console, Cockroach's DB console, to identify bottleneck, a response time bottleneck query. Remember how we bubbled up using statement time in the SQL activity page statement fingerprints table. We bubbled up a select star from book table, which was just a big giant query retrieval of 10 million rows from the book table. And what we did is we tweaked it a little bit by putting a where clause on it, because what we needed to do was the actual business case or the use case needed to find books within certain weeks, within a 7-day period, that were $95 and above. And that had previously been done in the application. They were selecting all the rows, and then they were using basically filtering within the application, not the SQL at the database level, to get down to that filtered kind of content that I just described. And we threw a very basic covering index on top of that, and we really chopped down our response time. So essentially what we did is we did these 2 steps, and then we just started to go in and we used this explain tool to give us an index recommendation, a covering index recommendation. And that's where we stopped last week. So what I want to do is then really dive deep into this right here. I mentioned that last week, that I want to go deep into what it means to use explain, analyze, and explain a little bit to tune a specific query. We're going to continue to focus on that select all query. And I talked about how what we wanted to do was have an empirical method of using explain or explain analyze to dive into a specific bottleneck query. And so if y'all recall, I went through these what I call empirical tuning steps, where we establish a baseline. So we'll go through this in some detail here. We're going to establish a baseline. We're going to run, just select star from book with explain analyze and see what its execution time is. We will then we'll record that execution time, as you can see here, because we don't want to lose track of what that original baseline was. And we're going to make a single change to that statement, one and only one change. And then we're going to test again with explain analyze, and we're going to record the execution time. Now, what that does right there, by making one single change, I talked about that last week, is that we can establish some causality with that single change. What's the causality that we're trying to sort of identify? Whether or not that single change increased or decreased the execution time, right? So one single change, nothing else, has changed between the baseline and the first test that we have. We compare and we just say, did we improve it or did we not, right? And then once we do that, we'll make a second change, and then we'll test it and explain analyze. Then we'll compare that second change to the first change, the test, and we'll ask the question, did it increase or decrease the execution time? We'll keep doing that until we no longer can get a better execution time. That tells us theoretically that we've actually tuned that query to the point where we've got it optimally performing. Okay, so that makes sense.
Yeah, and so by patiently just going one step at a time, we can see the changes or the effect it's having, and figuring out if we're going down the right path.
Super important.
Or if we need to go in a different direction.
Yep, that's it.
That's kind of all it takes, to be patient and let the process work itself out.
That's it. It's critical. I mean, and it can seem, if you haven't done this before, it can seem a little bit daunting to do it. But once you get in and you do a couple of runs of this, it's like you'll go, why have I not done this before?
Right.
Because it's a logical, empirical experimentation process which leads you to the most optimal performance of that query. I mean, just the data does the talking. You know, it's not a guess. It's not spaghetti against the wall. It's not a rule of thumb that applies until it doesn't. I mean, all those types of scenarios sort of disappear. They can guide you, but ultimately it's the data that you're gathering as you move through this process.
And I think it's somebody, I don't know, somebody I had a query I had to fix, and it was a query that took 20 minutes to run.
Mm-hmm.
Only it was a business office app, so they got low priority, and so for years they suffered it. I went and dug in. It took me 5 weeks to kind of do what you're describing, and I figured it out, rewrote it, and went sub-second, and they handed me a piece of paper certificate award. And it was like,
well, these are important because
it was important, and it's like I kind of joke about that, but that was one of the most, I don't know, satisfying moments of my career. It's like, hey, I fixed this app for these people, and it helped them do their job.
Oh yeah,
it wasn't about me; it's about them. So this is the kind of thing that you can do, improve your queries and help your system out.
Yeah, absolutely. I mean, because this has direct results. What we're focused on is the user response time. We talked about that last week. That's one goal of SQL tuning, is to improve user response time. Another goal would be to increase or improve the throughput of the system.
Right.
It doesn't matter. Either way, your work is material.
Yeah.
It is material. It has an impact. It has an impact on users. Oh, wow, this is really a performant. You know, last week, this thing was so slow. And now it's like, wow, that's a huge improvement that users will tell you. The other one is, the other throughput one is, oh, even if we shave off, we take a certain query and we improve its performance by like 5%, but it runs hundreds of thousands of times within a given minute or 5 minute period. Shaving off 5% on that query has huge throughput.
Go shave off 5% off of your program manager's most expensive query and watch their cost drop.
It's infrastructure.
And that's awesome.
It's infrastructure costs, right? In order to maintain a certain throughput, you have to throw more hardware against it.
Yep.
This way, you're making the query as performant as it can, and that would streamline and make your hardware costs sort of tuned, you know, or appropriate for what it is that a tuned query can drive. So these are material.
Yeah.
That's the thing, is that once you get into this kind of process, there's just stuff everywhere that you can start using the skill set against. So now a key question though, before we get into this, that I want to just sort of drive is like, how do you know what a single change is when you're doing SQL tuning with CockroachDB? So I'm just sort of laying that out here. What is the single change? Well, you know, as we want to have, would be nice to have certain types of guidelines or rules to be able to sort of frame that. So I just don't want to start forming my single change with no rhyme, no reason. I'd like to have some kind of logical approach to actually do that. Right? And so Cockroach Labs has published what we call the SQL statement performance rules. They're in our docs. And essentially those rules are, number one, always scan or read, let's say, or traverse rows of data, read, scan, traverse, same thing, as few rows as possible.
Well, that makes sense.
Okay. So select star from book is not scanning as few rows as possible when the use case says, give me books from a certain week that are $95 and above.
And scan that. Well, that makes sense. Don't scan too many rows, because, well, you may say, well, 100,000 rows, I don't know. Is that a big deal? In a distributed database,
as few as
if
possible.
You're running like what Netflix has got a cluster with like 380 CockroachDB nodes.
Yeah.
What does scanning a full table look like in that enterprise? That would probably be a death knell.
Well, it's a question of like, what you always have is you have the business use case, right? So the business use case got to dictate, this is the information I need back. This is the data I need back. So the question is, you want to be able to get essentially your where clause, your filters, your where clause. You want to be able to reduce the number of rows just to what that business use case needs. No more, it's certainly no less.
Certainly no less,
right?
yeah.
But no more is the big question that we're after here. And that's what we're trying to say here. I mean, what that means is use where clauses.
Yep.
Okay. Number 2, you want to use the correct index.
Right.
Not just use an index, but use the correct index, right? And what I say here is, a statement should use index generally on the where clause. So when you have a where clause, that's what you look at for your index formation, right? Now, if you have joins, that's another topic, but joins, you also want to look at, well, what are the tables joined on, right? Is there potential there to be able to sort of index against that? But just with a single table, look at your where clause. Those are your candidates for indexes. Now, how you create them should be driven by that empirical process, right? But that's the second thing. So number 1, you always scan use the right where clause.
Yep.
Number 2, use the correct index. Number 3, use the correct join type. And we're not going to cover that today because we're only using a single table.
Sure.
But there's lots more information in our docs. People should go to the docs to check that out. But you want to use, CockroachDB supports all the, standard kinds of, Postgres kind of compatible join types. Choose the right join type to be able to essentially optimize the performance of your queries.
And this is your friendly reminder, CockroachDB is ACID compliant. It supports most of the ANSI spec. So if you can think of it, it's probably supported by in the SQL standard.
Yeah.
So use the right query.
Use the right query, right?
Yeah.
And that's basically the guidelines that help us to essentially, again, shape what is a single change. So that's what we're going to be. That's what we're going to be doing today, right? And so what I'm going to do is jump in here. Now I'm going to start. Last week, yes, we did add a where clause where we basically filtered by publish date and by price. But I want to just like I said in the slide a minute ago, I want to establish a baseline. So I want to establish a baseline that gives me what the original query. I have my notes here on the side, folks. You'll see me look every now and then on the side. I want to establish a baseline. And what I'm going to do, we ran this last week where I ran just explain. I'm just going to start out with explain here just to refresh our memory. Oh,
while he's refreshing that,
there we go.
Going to run that just as for those that are picking this up the first time, this is our test environment we use called Instruct, and it's running a 5-node CockroachDB instance in a single VM, and it happens to serve it up to us through a web browser session. So we have a terminal inside this VM that we're able to then analyze the system with.
And there's our 5-node cluster right there. You can see that right there. Whoop, there we go. Okay. And so here, let's take a look at explain real fast. We talked about this last week. Explain gives us a result back of how the optimizer essentially plans to execute this query. It does not execute this query. It's how it plans to execute this query. So let's just take a look at some of this right here. First, let's look at this thing, spans full scan. You should avoid full scans with CockroachDB.
Rule number 1, it said on the sheet, is that on the recommendations, avoid full table scans.
Avoid full table scans. Yeah. And what we'll see in this, so we're reading here, this whole section, but we're looking at spans. We're saying, what is that? So let me just sort of dive into this. I think I have this somewhere. Do I have this somewhere? Yeah, let me see. Oh yeah, here's a good slide. Okay, so there's 4 possible values right here. I'm just going to focus on a couple. The full scan, which is what we see, indicates that the entire table is being read. The entire table. 10 million rows in this table. You do not want to do that. No. That is not performance. The least performant, essentially, as you work your way down this list, When we start to get some kind of a where clause in here, that's when we start to get super specific, right? And that goes back to what we were describing a moment ago, which was we want to scan as few rows as possible, okay? So that's, again, I won't go into all, this is, there are various situations in which we get a full scan with a soft limit and limited scan. Please check our docs on this. Ideally, what we want to do is get down to a where clause, which is somehow indicated in this kind of structure here. In this case, it's just saying where book ID equals 1, let's say, as an example. That could be a where clause.
Because then in this situation, it knows, okay, I don't have to go to every node in the cluster. I could just go to the specific nodes that have the exact rows that I'm looking for.
Yeah, in this case, it's like I need to find somewhere where the row is located, which says, book ID equals 1. Just give me that row. Okay. That's all I need.
Cool.
Right? So what we've got there is this sort of spans. The other thing we have here is table. What does table equal? Okay, so table has 2 parts to it. It has the name of the table, but it also has the key or the index, let's say, that is being used in order to perform whatever this scan is. So in this case, book primary key kind of tells me, right? This is just looking up this material, scanning it by the primary key index of the main table.
Okay, right.
Okay, that's all it is right there. Now, stats we'll come back to a little bit later on, but statistics, for those of you who've been around the database world, I mean, the database, what it does, all databases, CockroachDB does this too, is it takes a sample. So if you see up here, we have a book table. There's 10 million rows in there. The statistics have been gathered. It's a sample of the data from that table. And those statistics are what the optimizer is using to plan out how it can most efficiently run a query. Okay. So it says missing stats at this point. Those stats will probably be generated very soon. They're automatically generated usually. So let's first go back to this. And what we're going to do is we're going to add in analyze here. Okay, now the difference between analyze, I'm just going to hit this, let it run, is it will give us the plan. It'll give us information that we saw up here, right? But it will also execute the query.
So it's given it, it executed the query and it's given us like triple the information that we just got a minute ago from just plain old explain. Because it actually has real information
about the execution itself.
Execution.
Okay. Now that was like, basically select all from a table with 10 million rows. So this is, we're not running this query amongst, several 100,000 like we did with our load test. This is just one boom in and out, right? Now, execution time is a lot better on that than what it was in the load test with all those other queries. Remember, we ran at about 24 seconds, I think, when we did this last week.
Yeah, we had a load test, and it ran the select star query. It took 24 seconds to execute. Then we added a where clause, and that brought it down to 15, which was a 40% improvement, but not really good enough for material gain.
We need to be under 50 milliseconds.
And then we went and the explain command gave us a recommendation for what's called a covering index.
Yes, and we'll see that in a second, just as a bit of a rehash. And so here, what we do is we get an actual, let's take a look at this. This could be a little bit, by the way, like, wow, holy moly, do I need, whoa, okay, there's a lot there. Okay, let's focus on what you need to know, right? What do you need to know to tune a query, a bottleneck query? This is critical. Execution time is critical. We're not running in a multi-VM environment. Remember, we're running all of our nodes on one VM for training purposes, but network is also factored in, giving us a total right here, okay? But let's just, this is still a really good indication. Network should be much smaller. So we have an execution time of 6 seconds, essentially, all right? The other thing that we saw a second ago is it's scanning the entire 10 million rows. It's using the primary key index to do that. What it does then is it gives us an actual number of rows. It can give us that actual number because it ran the query.
And we didn't have that before because it was a guesstimation.
That's right. That's
Okay.
right. It was. And it will give us an estimated. We're not
Yeah.
seeing that here because the missing stats are there. We may actually generate those if they don't generate in just a moment, but we'll come back to that. Okay, so here, that's all we need to see. Execution time. What's the span? In this case, full scan. We want to reduce that.
Mhm.
What's the table? What's our actual number of rows? Okay. So what we're going to do with this is just go in and establish that as a baseline. So I'm going to grab just off on the side. We have a nifty little tool in here. You could do this on a piece of paper, a Word doc, whatever. It doesn't really matter. Spreadsheet. Is I'm going to indicate what the query is. What was my time on that? I think it was 6 seconds. 6, that's milliseconds. So 6,000. Tuning, let's call that so we have that as a record. Let's call that the baseline. The original statement, let's submit that in. Poof. Okay, so this is a record. Then let's go in. What we're going to do is test what we had last week, which was the addition of the where clause. Whoops. Let me get that. Just copying it from my notes here. Oh, so why is this not working?
This is what I call proof that this is a live demo.
It's a live demo, yeah. When your copy and paste is not working, right? There we go. Okay, so I think Greg, everybody can see that, right? Explain, analyze. There's our where. Remember that we did that last week. Let's just run that and see what explain, analyze will give us back. Okay. So now we've gone down to a 4.3 second execution time. We still have a full scan. We want to reduce that.
Right.
Right? We're still using the primary key. Last week, we got to the point where it was like, oh, well, it would be really good to perhaps add a covering index to it. I'm not going to go to explain here to do that. I'm going to instead, what I'm going to do is just build a little bit of a simpler index, just to give us a kind of an experience of like tuning kind of more incrementally, if that makes sense.
Right. Yeah, that makes sense.
Now, the other thing I want to do is just talk about, there's a little bit of a new structure that showed up here. First, we had this thing called scan, which we saw before. Remember? Right? We had this scan section right there, which was just, telling us some crucial information about what's being, scanned in the table or read or traversed. But then we have this new structure, nested structure up above called filter. So let's kind of look at this a little bit and think about what's going on here. Full scan, book primary key, 10 million rows. We saw that before. Then let's look up at the filter. It's kind of intuitive. We can say, okay, filter. Oh, look, there's the where statement or clause that we had, right? By publish date, right? And price, we can see that. Now, what's interesting about this is, the way to think about this is you always want to, and I actually have a diagram that I'm going to pull from somewhere. Where's the diagram? Because I think it's really useful to see it visually. Oh, yeah. So what you always want to do is you got this nested structure. First thing you want to ask is what is actually matched to what in the nested structure? Okay, so we got scan and we got filter. And so what I did in here is said, okay, well, the full SQL statement, the select from bookly, book, the table, corresponds to the scan in the output, right? That's what that is, which makes sense. It's like, give me all the rows, okay? Then the filter, which we can see right here, ergo, corresponds to the where clause of the statement.
And in that situation, the only way it can know whether or not a given row meets the criteria is it has to look at every row.
Yes.
To figure out whether it's in or out.
It has to. It has to. At this point, the only way it can traverse this is that we don't have an index. We took the index off.
Right.
right? So right now it's using the primary key. So it's looking through the primary key for this table, which is, I think it's book ID. It's what we have.
Yeah.
It's not published date. It's not price. It's not any of those other things.
Right.
So it's looking through that and has to scan all of those in order to see if any single row meets this condition. Okay. And so that's what we're laying out here. And the way that you always read the explain, analyze, or explain itself is you always read from the bottom up.
Right.
All right. That's so you can think of first select from book, gives me the actual row count of 10 million rows. Then the filter is applied, which then reduces it down to 3,196 rows, meeting that condition. See that right there?
And I mean, that's a big reduction. Like, that's why I went from 6 seconds to 4.3 seconds, because now you're no longer sending, 10 million rows over the wire. You're only sending 3,000, but it's still not very good. It's still got a full table scan.
But this is actually producing. It's like first producing this in order to be able to traverse with this. This is still really bad.
Yep.
We do not want this. So what we talked about last week, which we did really quick, is we used explain. Let me get it. I have my notes here. And in fact, before we do that, though, we should always, I'm not following my own methodology, is we should go in and record what our results are. We did a bit of an improvement. So this is what we did. That's our query. And what was it? 4.3,
4.3, I think.
Wasn't it? 4.3, yeah, 4.3. So that's 4,300. So to your point just a second ago, 43. Let's put a little note in there, something like, we add the where clause. Okay. So to your point a second ago, that's a nice reduction. 6 seconds down to 4.3. That's nice. Okay. But we still have a full scan.
Yep.
So what we want to do is see if we can eliminate the full scan. Now, we did that last week by essentially applying that second rule that we had, which is, use the correct index, right? That's what we did last week very quickly. We used a basic covering index. I'm going to do something a little bit, I'm going to make a very, very, very simple index, just so that we can see what the difference might be when we use what I mean by a simple index. There we go. Okay, so let's take a look at this. What I'm doing is creating an index on the book table, and I'm using publish date. Publish date, because that's what we want to search by mainly, is out of the gate anyway. Let's try publish date. Okay, so I'm going to create the index. As we saw last week, we can even go in here and just take a look. Creating an index means that it will create a new structure. There'll be a little bump on that number right there.
So what it's going to do, it's going to go make a secondary data structure, and it's going to, what it's going to put in there, it's going to put the publish date column, and it's going to sort on that column.
Yep.
And then at any given entry in the index, it'll have the reference to the row of the actual table.
Yes. And we can take a look at that. You can see how it bumped up a little bit there. What was that, 8 up? So we can do show indexes from book right here. And there, what we had before, this is what we were searching on, which was the primary key index. Now we're searching on publish date, which is now in ascending order. Okay, so that's cool. One would think, we've solved the problem, right?
Sure, it can. I mean, you give it a criteria, it can jump in whatever exponential time, I guess logarithmically, it can jump to and figure out, here's the rows I'm looking for. That's probably a distinct improvement. But is it an improvement enough?
Well, and what we're going to do is we're always going to make a single change, and we're going to run explain analyze. Okay. So now we're going to go back. The only thing we've done is we've created this index. Okay. So we should have, I think, where is it? There it is. So it's the same run that we did a minute ago, just an index has been changed under the covers. Okay. So let's run this. Let's see what happens.
It's thinking real hard.
Yeah, it's running the query. Ooh, it's running the query.
Smash like if you're getting value.
Holy moly!
Yeah, smash like if you're getting value out of this, and if you want to find out more about what we got going on here. What do we have?
Now, this is very interesting. Sometimes I might run this a couple of times just to see if I get, but this is, okay, first, let's just record this as is, all right? Now, let's think about what we have. That's 10.4 seconds.
That's more than the last one.
Yes, it is. So why don't we, first, let's keep to our methodology.
Okay.
I'm just gonna copy this, and then we'll do some analysis. Okay, I'm gonna copy the what did we use as a query? It was the same as the previous. That was like 10 seconds. I might redo that again sometimes just to see if I get a little bit lower. 10.4. Actually, why don't I do that just so I have that? Sometimes I'll run this. CockroachDB has some caching capabilities for queries, so sometimes it might actually cache. It does some sophisticated stuff under the covers. So just see, I'm going to see if I get this replicated at 10.4. Maybe it'll be 5 or 6 seconds.
It's looking still kind of expensive if we're sitting there waiting and talking.
There you go.
10.2.
I got 2 in a row. So we're definitely, we can say 10 seconds.
10 seconds. Yeah. 10,000 milliseconds on the metric here.
Now let's record this. There we go. What was the tuning? We added and I'm just going to put a little note, a simple index. I'm going to put something in here that I have just on the, okay, so added a simple secondary publish date index. And then I indicate here that there's something called an index join problem. Let's go back.
Let's just submit it and then let's look at that, explain, analyze.
What I've done. Now that's crazy when you look, like, we're getting worse, right? So what am I talking about? Index join problem. Okay, look at this. Remember before, we essentially had filter and then we had scan underneath. We always read from scan up, but that was the structure, right? So first of all, this is much better. We don't have a full scan anymore. We have the week that we put in, right? January 1 to 7/20/2022. That was our period. So there's 1 week.
That could be a single range, maybe that, or it could be a one, it only has to go to one node or definitely a subset of nodes. It doesn't have to go to every node anymore.
It's not.
So that's a bit improvement.
Well, and we can see what was the actual row count that this produced. It's not a full scan.
Right.
There it is. 63,000 versus 10 million.
That's huge.
That's much better. Okay. Much, much better. Well, finally, our stats kicked in for whatever reason. They took a couple of minutes to actually be analyzed, but now we have stats. This is an estimated row count, meaning it's based on the statistics. It's estimating that it was 77,000 that needed to be traversed or scanned based on this, right? This essentially where clause conditional there. The actual was 63. That's not bad, right? That's in the ballpark. This confirms that we're using the index we created.
That's the new index that you just created a minute ago. The simple index just based on publish date.
Yeah, just based on publish date. Now, the trick is what's inside of that index? Let's just pull this up again. Show indexes from book here, okay?
So we can see it.
So we can see it. There it is.
What's inside? It has publish date, it has the publish date, and it's got the book ID. So when you look up by publish date and it gives you the book ID to then go back to the book table.
That's exactly what's going on. This in the index. So once we find that week using publish date, we're now using the book ID to do a join, what's called an index join, to the primary key table to look up
and
the rest of the information we need.
And we're having to join to that table 63,868 times.
Exactly.
If it was a single row, that would be one thing, but 63,000 times,
but
that's a different cost.
It's just jumping over 2 tables. Joining 2 tables is going to be less performant than just going to a single. We do that, but it doesn't matter when we do that in our queries or we do that here on the background. It's actually having to do that because there are actually 2 table structures that are needed in order to fulfill this entire query.
That's
right?
what we have to do. We have to go back to the main table to get all the columns that we want to answer the query.
That's it. Exactly. So that's why when we look at this thing is like 10 seconds, even though we're not scanning the entire table.
Right.
We're doing a join across two different data structures, right?
So basically, it's a bit of a cliche when people say the database is slow, or more accurate, some people say the database. So the answer is your query is slow.
Well,
the database, but somebody blurts out, make an index. Well, that helps, but if you don't make the right index, then it can work against you.
Well, that is it. That's it. Exactly. And it's a question of like, how well have you tuned your query for the specific database that you're using? Cockroach is distributed, right? It's got great features and functionality, but you want to be able to play nice with it. And part of that is tuning your queries in this case, right? I mean, any database, what we're showing so far is applicable, right? Okay, so now let's go back here for a second. And I'm going to take us back to where we were, because this is where we were kind of last week, right? So now what I want to do is I want to get in here, and I want to, first of all, drop this. I'm just looking for my notes here. What's the name of that? There we go. Explain. Yeah, there we go. So I'm going to drop this one. Whoops. And in fact, you know what? I'll wait. I'm going to do an explain on this. First of all, I'm going to take us back to where we were last week. I'm going to just run explain. If you remember what we did last week, right here is I ran this in last week's session. There's no analyze in here. It's just explain. So it's just going to analyze this on its own. And it's going to say, hey, wow, it gives us a suggestion. It says, I see what you're doing. Oh, this is really cool. We do this. But what it wants us to do is in a way here, it's recognizing the problem that we had, which is the index join and all that kind of stuff. It's giving us an index recommendation, which we saw last week. So it's that covering index. Now, why is it doing this? We just talked about how this only gives us part of the query.
Right.
It has to jump to the main table and the primary key index to get the rest of the columns needed for this query to be satisfied. Okay, so what it's doing is it's saying add storing to it. We did that last week. Now, in this case, what we're going to see is that the business use case actually specifically requires title, author, price, but it's not asking for format. Now, I know that because I've looked at the business use case. It's like not asking for format. So we can do a little bit of an assessment right here and saying, do we need to create a full covering index that covers all the columns? Because when we create a covering index across all the columns and our queries don't need that,
we're wasting space. We're using up space that we're not tapping into.
We're using space. And also during our writes,
we have to update the index which also is costly. Right? So we need to reduce that from becoming a problem down the road.
Yes, so it's good for both. You want to save space, but you also don't want to have format. It doesn't need to be updated because it's not used by. Now, if we had a query that required all of them, yes. And so far, what we've got a select star. What I just said to you is that we don't need format, so we should not have select star in there. We should specify specifically what columns we need, not just slap a star in the statement.
Another reason to not be using select star in your queries is that go read the actual requirements. The requirement probably doesn't say give me all the columns. So only put in what the use case is demanding in your customer requirements.
So what I'm going to do is I'm going to create a more targeted kind of covering index.
And this is different from the recommendation that Explain is showing right above.
You see that?
you've done you're able to do a little bit more analysis. Explain can't go read your business requirements.
It can't.
So,
how does it know what your business needs?
So it doesn't.
Right?
So
it's going to hedge its bet. It's going to say, now, if we had a query, as I said, if we had a query that used all of them, we should use that. And then this query that we have here that is a subset, along with the one that uses all columns, would use the same index. That's good. But if we don't have a query that goes and grabs all those columns, you don't need to do that.
I think you said it before. No premature optimization.
That's right. And there's a burden, not just storage, but also during the write process.
Yep.
So what I've done is I've reduced down to 3 columns. Only the ones that I needed right here. And we'll see that reflected. Now let's create that index. Let's go in. Let's just take a look.
It's going to probably eat up more space there. So
Yep.
we're at 9.1 gigabytes of usage here in our fun environment.
Yeah. And it'll start, as it's building that up, it'll start to bump that up in a second or two.
So by the way, if you missed last week's show, first of all, hit the subscribe button, ring the bell, and then after the show is over, don't leave the show right now, people. After the show's over, go back to the channel and catch the previous one, okay?
Oh, there we go. You can see that starting to bump up.
9.5.
9.5.
Okay.
There it goes, 10.2. Building that index data structure. Might have a little bit more of a bump up there. Yeah. There it goes, 10.3.
And this is the DB console tool that comes with every Cockroach, that comes with CockroachDB. This isn't a special tool. You've got this if you're already playing with CockroachDB or using it in your production.
That's it. Yeah. And it's great for development, right? It's very easy to get in there and kind of see what you're doing in a targeted way, specifically around things like SQL tuning. It gives you like a lot of capabilities. We may have built that up to where it is. There it is. It's done. Now, the other thing we're going to do is recall from a second ago, we built that other, right? Yeah, there we go. Remember that was the one that we used before, which wasn't very effective. Always good to clean these things up.
Yep, super simple,
right?
Because right now, the system is having to maintain 2 indexes.
Whoops.
So if you're going to replace one with another, I think the structure you did is you created the new index.
Yeah.
Before you deleted the old one.
That's
so that you're covering it. You're covered by an index either way.
Well, that's actually good practice. So sometimes when I'm in a SQL tuning, effort, you can do the reverse, but typically it's good practice to get in the habit of like create the new index, drop the old, create the new, drop the old, because you always have that coverage. Especially if you were doing something in production, you would never do the reverse, right?
I mean, it's the adage they tell you if you're going to go get new life insurance, wait till the new one is in force before you cancel the old.
Right.
Don't get caught.
That's right. And so that one's now been dropped, and kind of the database's garbage collection will kick in. Actually, I've set this very low. This is just an aside, but I set the basically garbage collection time to be very, very low in a SQL tuning environment, so that my indexes that I'm dropping like this get cleaned up pretty quickly. The default time is 4 hours, and I've dropped it down basically just almost to a minute, just to clean that up pretty quickly. Okay, so now what I want to do is run explain analyze. And let me see if I can paste that in there. There we go. Okay, so now let's look at this. Some things going on. So I've added in the specific columns.
Oh yeah, instead of select star. Yeah.
Right. So I'm improving the statement. This is still the stuff that we saw before, the where clause, but now we have that new index under the covers. So let's try this. Whoa.
That was instantaneous.
Okay.
Almost.
All right. Now let's analyze, well, first let's record. So milliseconds, we're down into milliseconds now. We're 63 milliseconds. So let's get our tracker up. So we're going to record this. I'm going to just make note of the fact that I have specified right there, right? The columns, just, the where is the same. Was that 63
milliseconds.
63 milliseconds. That's a dramatic improvement. Oops, that's not what I want. I want right there. And I'm going to just put some notes in there. Added a storing clause right here. Okay, added the storing clause to publish date index, which avoided the index join. Okay, so we had the index join above. We added the storing clause. We've avoided that. That was huge. That's a huge drop right there. Huge drop. Okay. So, and the reason, let's take a look at this. If we look at our explain, analyze results, number one, we're still no full table scan. Amazing. We're still that same 63,000 rows of actual data that we looked at. We're using the new index now. It has an index 1 on the tail end of it. And we no longer have between filter and scan an index join. It's gone.
No need to go back to the main table because it's right there in the index.
It's right there.
The columns that you need to answer the business case.
That's it. It's done. So what we can see is that of these 63,000, there's a little bit more, 63,868, that this particular scan, pulled back. The actual ones that would meet the price is greater than 95 are 3,196. It's a much more efficient query.
And that was a huge jump from what's 10 million row table.
Yeah. And we just want to keep whittling down in a methodical, empirical way, right? Let the data do the talking. That's dramatic. So now it might be interesting to try. There's a way of building an index, which is called a composite index, if you haven't heard of that before. And so what I'm going to do is I'm just going to paste it in and show you what I mean. Okay. So what I did in the previous, if you recall what I did up here, let's just look, where is my creation, my index? Yeah, remember, there it is right there. Okay. So I had published date. I'm indexing on published date, and I included title, author, and price. Price is also included in the where clause. So what I'm proposing down here is taking price out of the storing clause and adding it into the index itself. So the way that this index structure will be created is published date will be ascending, and then from that, within each one of them, price will be ascending.
Okay, so let me get that one's a trickier one to visualize. So it's going to sort first all the entries based on the published date.
Yep.
And then within each subset there, it will then sort the price. And because in this query we know it's gonna be looking at both of them, it's going to be able to shrink when it does the scan on the index, it can shrink the data set potentially to a much smaller set.
Yes, more efficiently completing that where clause all the way down. Now, where the rubber hits the road is when we run this and we actually see. Let's see if there's any kind of an increase, decrease, or no change at all.
Because that's our methodology, is to go back and run it again.
That's it. So what we're doing is we're going to create that index. We'll go in here, creating the index. We should see this number start to bump up a little bit. We'll drop the other index as soon as that one's underway. There goes 9.9 gigs, starting to build the index.
And I guess while that's ramping up, a good point is that if the column is actually part of the key, in this case, the key is both now in the index, is the published date and the price.
Yes. There's
no need for it to be a part of the value.
No,
right-hand side.
There already.
Because it's there already, and CockroachDB knows how to use that.
Yes, and this we'll see in a second. We'll take a look at the index, because see, all the information is there in the index. The index is just structured a little bit differently. And it's just because what we've done is we said, go in ascending order on published date, and then within that, as you said earlier, it's like order in ascending order the prices, and then have the other two columns there, right? Because it's storing does that with the other two columns. And it looks like we're probably there. We've got that. So what we're going to do, and actually, let's just take a look at that, because we'll see the previous index from book. Okay, Okay, so this was our, you see this, the direction right there, published date. That was our previous index right there.
Right.
Okay, you can see that all the information is there. because these other ones, title, author, price, they were storing in the storing clause. Now what we've done is said, okay, make those both ascended in that
And
order.
that's also the order. It's the first.
got
The
it.
first part is the published date,
got
and
it.
the second part is the price.
See the sequence index order right
Yep.
here.
It
1,
puts it
2,
in-
3,
yep.
4, 5, right? And we've got the other 2 from the storing clause. So let's get rid of, we don't need that other index, right? I think I have this here. No, I don't have that. Oh, shoot. I do that every time. It's the way that the environment kind of copies things automatically. So let's drop that previous index. I could type that out, but I'm going to do this to make it quick. So that's getting rid of the first index right there. Drop. Okay, so that'll be garbage collected. Now let's go back, test our theory. It's our hypotheses. Will this be better? Will this be worse? We don't know. Let's run it and see.
Stick to the methodology. It works.
Yep. Whoa. Okay. That's actually pretty good.
38 milliseconds, and we were
at 63.
Well, we shaved another 50% off.
Right? Right? I mean, that's phenomenal. Now, let's first stick to the methodology that we have. Let's go in and record our results. Then we'll do some analysis. Okay? So the first thing is we haven't changed. Whoops. We have not changed anything in the query. Right? So here's the query. Our X, I think, was it 38? Was it? I think it was 38 milliseconds, wasn't that?
Something like this.
Let me
38 or
check.
32.
38 milliseconds.
Yeah.
You know, that's significant. What we can say is just to keep notes. We always want to keep notes about what our tuning intervention, our single change was, to give us some context when we're analyzing, especially later on. Okay, so that's amazing. That's really good. Now that may not have been the case, but we would know now. Let the data do the talking. So we created a composite and we got even better. Doesn't mean that's always the case. You should always test the creation of composites or not to see which one is better. Okay.
And I think that we mentioned it last week. I don't think we mentioned it here, but one of the service level objectives we defined in this scenario was to get the thing below 50 milliseconds.
Yeah.
And this round, we finally got it there.
We are there. We are there. We are there. We are definitely there. And
it's neat to look at the structure now that Explain
Yes.
Analyze gives us, because now we can see the spans, and hopefully maybe you're starting to get the vibe of how this reads. But
yeah,
you can see slash, and you see the date, the published date, and then slash a price.
because you can imagine that index now is ordered in this way.
Yep.
Right?
And so it found the first entry that satisfied the criteria of price being above 95. And that's
Yes.
where it starts. And then it
and
went
then it
on
went to the
the
end.
Presumably, I guess it was that to the end of that particular range for that index.
Well, what that is it's using the date, right? It says I go
Right.
from January 1 at 95, so I'm not at 42 on that date.
That's
I'm at
right.
95 and above, and then I'm going to go to the end of this.
And then it's the filter will then take out whatever remaining rows based on price.
And it reduced us down a little bit.
Yep.
You know, like 55. I think we were at 63 off this
Yeah,
before. We still have the same amount exactly.
So we're still getting the same final results. So it's the same correct answer.
This is showing us that perhaps this is just a bit more efficient. This is something we should really strongly consider, right?
Yep.
You know? And then, okay, so now just to make this fun, okay, and this is always
This isn't already fun?
well, I mean, just to make this funner.
That's right. Faster,
funner. Is okay, so as we're diving into this particular query and we're really digging into the business use case and all that kind of stuff, making sure we're adhering to that, it's always got to meet the requirements of the business. The data's got to be correct. If it's not correct, doesn't matter what we're doing here.
Right.
We dive into it and we realize for this promotion that we're doing with these super customers, remember it's super customers.
Yep.
What we're doing is we're doing a promotion that says, here are a bunch of books published during this week that we're going to give you a sale price on.
Right.
And what we're doing is the reason why they're super customers is they typically tend to buy some of our most expensive books. Our books go from $1 to $100. And the most expensive books are $90 to $100. We're never going to offer them a promotional price on a book that's normally priced at $32 and drop it down to $25. We're only going to target that week books that are
That's
between 90 and 100. So what does that tell us? Oh, wait a minute. Can we build an index that specifically only includes those price point
Can we
books?
shrink the index to an even smaller size?
Yes. And that's called a partial index. So what we're going to do is we're going to jump into this. And in this case, I'll show you the partial index right here. This is how we're going to do the partial. We're still going to keep that nice performing composite that we had before. Hey, that was great. Now let's keep the storing, but we're going to add a where clause. That says anything that is equal to or above 90, build the index just with that, 90 to 100. That's all we're going to get.
I think about everything I can think of in SQL will accept a where clause. So use them. Use them.
Exactly. So let's create this. And this one we can see. It'll take a second or two.
Now, if this is a subset of it, this should be a smaller. Now, the data it's going to grow because it's adding to it because we haven't cleaned out the previous index. Yeah. But this index should take up much less space than the.
You see the jump? That was a small amount, 9.2, because it's a small. This is much smaller, index. Right? So let's go back. It's done. Now, what we need to do is we need to show. We still have that old index. Let's go in and clean that up. Right. So that old one, I think was, oh, you know what? I think it's, we don't see that here.
It's the,
I think it was.
Well, the explain, analyze above shows what it used, which was the IDX.
One. So that's it. Perfect.
That's the one we can drop.
That's the one we're going to drop. Thank you, Greg. So, and do I have, I have a thing here that'll cover that. That's perfect. So we're going to drop the old one, which is the full one, and we're going to use the new one, which is index 1, which is the partial. So let's drop that.
May free up a lot of this space.
Yeah,
but we're not doing this because we want to save this space. We're doing this to make a smaller result set or smaller index set.
Yes,
to speed up the improve the efficiency. Yeah,
but we also don't want to leave that other index in there. You know, even if the optimizer would be smart enough to ignore a bunch of indexes that it doesn't need to use, because again, it takes up space, and it also means every time we write, there's a bunch of columns in there that have to be updated potentially.
So there's no need to take that to
just clean it up. Clean it up. Right. Okay. So now let's go back, and we're going to run the same query on the partial index and see what we get. So that's the same query we've been using the last few times. Holy moly!
What, 6 milliseconds?
Right. Okay.
I don't have a sound effect. We need to be ringing a bell or something for the show.
So this is one thing you should always be fit, and this is something that you would only understand. The business use case said, "Oh, we don't need to look at all of the all the prices. We're only looking at a subset of prices."
Well, I can see that their actual row count for that scan on that part is it's less than 6,000 rows, because it didn't have to scan all the books that were $60, $70, $80 or $5.
Yes,
and that cut out
huge swaths.
That cut out 90. Well, it cut out 90%. You pick the top 10% of pricing. So.
Right. So let's make sure we finish off. We get really, we have to stick to our methodology. We'll go in. We will use the same query we did before. What were we? 6, I think. 6 milliseconds. 6 milliseconds. What was our tuning? It's just simply we created a where clause. Okay, and that's where we have gotten to.
Well, print that out, take that to your program manager, because you then asking for a bonus. I probably won't have it. But anyway, that's good.
Well, what we would want to do when we get here is, let me just take us back to our original methodology, and perhaps we can come back, even if you'll have me back, Greg, is that if we get to the methodology, there we go. So essentially what we did is this right there. Okay. We got down to this point where we took a specific query and we tuned it. Now, what we want to do after this is we want to take that query that we just tuned. Right now, we've got a partial index. We've got a reformulated query, right? We've got amazing times with explain analyze, but we want to go back into our load test environment. And we want to put that in the context of hundreds of thousands of other queries and see how that runs, just to verify, because right now we're executing one execution with explain analyze. We want that query with its partial index to be running amongst all of our applications and see what the performance is. We should still be getting into that very, very small, millisecond kind of, statement execution time, but we want to verify that. That's number one.
Yep.
Number two, what we want to do is then see if any other queries bubble up.
Yep.
Right. And then we would repeat the process and eventually stop. So maybe if we do another one at some other point, we'll go through steps 4 and 5, and that's it.
And then just each time you fix a query, it falls into the fray because now it's doing what it needs to do efficiently, and you can see what's next, what bubbles up to the top of the file.
Yeah.
And it's almost like every shop should have some amount of time allocated to say, let's just go back once a month or what have you, go through, sift through, and look at what's the work, where can we improve efficiency, and just a continuous fine tuning of stuff.
Yep, absolutely. That's it.
Well, that is powerful with both the DB console and explain analyze at your fingertips.
Yes.
It helps us tune it. We got some, I don't want to say the word crude necessarily, but a suggested index, but we're able to go way beyond that.
Yeah, we want to dig.
We dug in and got a real solid index that actually does the trick.
That's it. Exactly. Use that as an initial guide. It points you in the right direction, but you should always be doing that kind of methodology to really verify and see if you can hone it even more. Right.
All right. That sounds great. I think this is a great wrap point. So don't forget to subscribe to the channel and stay tuned, because we're probably going to have more of this stuff.
Great.
Smash like if you want Doug to come back on the show.
This episode is over, but your learning has just begun. Visit CockroachLabs.com to find all kinds of content to expand your knowledge.